All right. I think we should first discuss the exam. So let's take a look at the solutions here. Okay, I have the two programs. Let's look at the first question. This is the library. So all right, here is what I have for the library modification. You have to get the member name. So I introduced a new method, get member name. Given a request object, it gets the member ID from that request object, searches the catalog, and stores that in a member. And if it is not equal to null, actually, I should have one more thing here, else result dot set result code result no such member. Yeah, if I missed that here. So I set the result and then return it to the library. And the user interface should have a new constant get member name. And you need to use that in your process, get member name, and then you call a method called get member name. So it gathers the member ID, stores it into the request object, and sends it to the library, calling the get member name, and then the result is stored here. And if the result is not, if it is equal to operation completed, I display that member name over here. Otherwise, I flag an error message. That is the first question. The second question, we have, I will just look at a couple of these classes. We have to refactor the class room so that you replace all conditions with polymorphism. And we have deleted all the type related objects in this new modification, and then we have made room abstract. The reason being compute total charges per night is an abstract method in my implementation. Some of you did not make it abstract, that's perfectly fine. I didn't put anything into this method. I put all the computations in the subclasses. In fact, almost all the computations have to be in the subclasses. The other getters remain, and the constructor loses the type field, but otherwise it retains the other parameters. And there are three subclasses. I will just show one of them, which is single room. It extends room, and the constructor is simple. There shouldn't be any fields in this class. And compute total charges per night is essentially the part of the room classes compute total charges per night with the code for single rooms extracted. That's pretty much it for the solution here. You can similarly create double rooms and suite. I have posted that solution, but I noticed that, I forgot to put an else condition in the library here. So that solution doesn't have it. I need to fix that. That is the code. Any questions about this? All right, let's take a quick look at the multiple choice part of it. I think I have made those things available to you, so you should be able to view the answers. So I'm not going to go through this in any great detail. Okay, so let's get to.
I have a question about a particular one, if we're allowed to ask.
In the multiple choice?
Yes.
Okay, interrupt me when we get there, okay?
Okay, thank you.
Yeah. First question, you cannot have data structures referred to in analysis stage, and nouns are used for determining conceptual classes. Sequence diagrams can be used to determine the functionalities. They can be used to determine at least some of the fields, because especially when you see those constructor calls, you can see those fields are probably, those parameters are going to be stored in fields. Then we use a cross symbol to say that an object is destroyed. We would like to increase cohesion and decrease coupling. Then there are three or a few questions on refactoring. If you have a long method and if you have two separate parts, then and if they use only methods, fields and methods in the same class, you probably want to extract one of the blocks and then put it into a different method. On the other hand, if you have a very small method, and if it is very cohesive, and if it is using only fields and methods of the class, there is no need to touch it. So don't do any refactoring. Now, if it is very long, and if one of the blocks is using fields and methods of another class, then it is time to move that fragment into a method in the other class. And if it is small, but it uses fields and methods of some other class, just move this whole method. There is no point in putting it in class A. And if you have two collection classes and if they have similar functionalities, then you should consider using generics to create a superclass that has all the common functionalities, and then have these two collections be subclasses, like that item list. If A dot equals B is true, then B dot equal, then B dot equals A should also be true.
Sorry to interrupt you, but are you supposed to share your screen? Because we're not seeing it.
Oh, yeah, I should have shared. Yeah. Sorry. Okay. Thank you for reminding me. Then question. Yeah, go ahead.
Answer. What if the answer is B? I was doing some research. It says that the hash code may not necessarily have to be equal. Unless there's like, so there could be a chance that that is not exact.
If A equals B, then their hash codes have to be the same.
I know, but what about B? Let me see. The
B. Oh, you mean you're talking about question 12?
Yeah, for 12. Yeah, the answer.
Okay. Let's. A dot equals B should evaluate to true only if A dot hash code is equal to B dot hash code. That is, we are saying that A and B are true. Then their hash codes must be the same. But if two objects have the same hash code, they don't have to be equal.
I know, that's why I said the answer for that one could be B, right?
That is wrong. B is wrong.
Am I reading it wrong? Isn't it like the exact the same except only
No,
if?
no, only if means only if the other condition is true. I mean, I am sure you have seen theorems in discrete math which say if I mean something is true if and only if something else is true. Maybe I'll spend a couple of minutes talking about this. I think it is a frequent problem in this class. Students have oh boy. Okay, I think I will probably, I can't use my, all right. I'll still use the white board. I think I should, we have to talk about it for a few minutes here. Okay, whiteboard. I'm trying to look for some good real life examples. Okay, let me try this. I'm not sure that this will work out, but I will try. Okay, I will go for a walk if it is sunny. Okay, that means whenever it is sunny, I will go for a walk. I will go for a walk. At least that is how it is in logic. Okay, only if it is sunny. This means if I went for a walk, it means that it is sunny. There is implication only in one direction. In the other case, it says, if it is sunny, I will be going for a walk. Right? So you could have, I mean, coming back to our situation, if you have objects O1 and O2, suppose they are equal. O1 is equal to O2. Then I think okay. I need some more. Okay, hold on. Situation. Then one's hash code. O2's hash code. Okay. Suppose O1 is equal to O2, then what we are saying is O1's hash code, if it is 7, then O2's hash code also has to be 7. Okay. That has to be the case. If you are saying that these two are equal, their hash codes also have to be the same. But it could be the case that O1's hash code is, say, 15. Then, and you find that O1's hash code is 15 and O2's hash code is also 15, but then I could have O1 not equal to O2. That is possible. There is no need for O1 to be equal to O2 just because they have to have the same hash codes. Do you see the distinction?
Yes.
Okay. If O1 is equal to O2, then what you cannot have is something like 10 and 11. That is not allowed. So this stuff is not allowed, right? So that is the difference between if and only if. Only if really means a consequence. It is in the forward direction. I'm thinking, I mean, it has been a long time since I did discrete math, so I can't remember all the theorems. Okay.
Yeah, Professor, there's like the truth table between the two. The only if has only two true statements, and the if on its own has 3 true statements. So it's usually just checking that third case is how you tell the difference.
You mean in this case?
The difference between if and only if is the truth table for if has 3 true statements, and the truth table for only if has 2 true statements. So you just look at that third one and see where the difference is.
I'm not sure that I quite follow. Are you talking about in terms of A dot equals B or in general?
In general, if you
Okay.
have a true false, because these are binary conditions, so you set up a table where you've got true and true, true and false, false and true, false and false.
Uh-huh.
For the only if, the truth table only shows true if they match. If it's true and true, false and false.
Okay. Yeah, you may be right, but I at this point, I'm not able to follow the thing. I mean, I think I need to see it written down somewhere. Then I can, yeah.
Yeah, verbal is hard. Sorry.
Yeah. Basically, if you have something like, oops. If I write something like, I'm not getting good examples. If I had, I should have prepared. I mean, if I were prepared, then I could have easily explained this. I'm looking for good. I mean, this is also, I mean, what I have here is not necessarily the best possible example. Yeah, okay, well, let me try this. Okay, let me try this. Maybe this will, John is invited to perform only if he can play the piano well. This means if he is invited to perform, he is able to play the piano well, right? Let me erase the other one. On the other hand, if I write John is invited to perform if he can play the piano well. So this means if John can play the piano well, it is for sure that he will be invited to perform. So if the second part of the condition is true, then the first condition is guaranteed to be true. Whereas in this case, if the first condition is true, the second condition is guaranteed to be true. You see the distinction between these two? In the first case, just because John can play the piano well, there is no requirement that he will be invited to perform. But if he is performing, we know that he plays the piano well. Whereas here, if he can play the piano well, he will be here. But just because he is performing doesn't mean that he can play the piano well, right? I mean, I could go and play the piano. I can't play the piano at all. But if John is playing the piano well, he will be invited. So if and only if, or if is one thing, only if is a different thing. Okay. So that here I'm combining the two, but neither of these two is true. Okay, let me go back and share this. This should have been matchable interface. It is not a JDK one. Before we attempt refactoring, you should have a good test suite so that you can check stuff after making modifications. T extends matchable K means T implements the matchable interface. The library system, book and periodical are subclasses of loanable item. The visitor pattern has the problem that it is difficult to add new classes to the hierarchy. And here, with book, periodical and loanable item, we have no author in the superclass. When you want to implement a new functionality, you just need to have a new visitor implemented, say new class. And what we have is the visitor is actually having that visit method, and you are having the accept methods call that visit method. The finite state machine, the number of states is 4 here. Number of events is 3. And then if you have a brush with a single button, if you press the button, the brush starts spinning, etc. So it is pressing of the button is an event. The spinning of the brush itself is not an event. It is actually the state of the toothbrush. The signal generated after 2 minutes. After 2 minutes, there is a pause, some signal, and that is also an event. So any questions on these?
Yeah, my question regards the last question that you just covered there.
Okay.
So I could see, I looked over the reading again, but the way that I read the instructions, it says that it would stop spinning after 2 minutes. And so I read that as the time ending being the event.
Yeah, it pauses spinning after 2 minutes. Yeah, well, so there is a signal generated by the toothbrush within the toothbrush. So that is actually an event. It is like the event in the microwave to saying that cooking is over or whatever, that cook time is over.
Yeah, you know what? I just realized I thought signal was like the little music that plays, and it was like a control signal. I see it now. Thank you.
Yeah, it is a control signal. Yeah, it is a control signal. Yeah. Right. Okay. All right. Now, what we need to discuss for a few minutes at least is the second group project. Okay. There is a document under group projects and a video. So you should first read the document, then watch the video. Because I'm only showing the dynamics of the stuff in the video with very little explanation. Most of the background is actually in the document. If you just watch the video initially, then it may not make much sense. So let's go over that. Give me a minute. I need to find where it is in my Zoom window. It's so hard to find things. Okay, here. All right. What do we have? All right. This uses a finite state machine approach. So the problem is here. This is a security system for a home. This is very reflective of security systems available there. So this is not an imaginary system by aim at all, not an imagined thing at all, right? So in this system, you are trying to protect a home when the owner is not in the house. Like you go to work and nobody is home and you don't want people coming in at that when you are away, right? That is one situation. The other situation is you are probably not in a position to see that there is intrusion, most probably at night. You go to bed at 11 o'clock, maybe, then you arm the system. That is the terminology, arming, right? And if anybody comes into the house at that point, then the security system will catch most of those intrusions, hopefully. So what you do is, supposing you are going away, then in this security system, which looks like this, partly at least, there are, I'll tell you why I say partly in a minute. When you are going out, what you would do is you would press this away button and leave. Then during your absence, if somebody comes into the house, they might come in through one of the doors. So there are 3 doors possible in this system, and I am calling them zones: zone 1, zone 2, and zone 3. If anybody comes in through one of the doors, a signal is generated in the real world. So there is something in the door itself that triggers some kind of electrical signal, which makes the security system go into a warning mode when you have to actually type in a password. If you don't type in the password in the 1 minute or so that you get, this system will think that the security has been breached, and you will probably have the police called. So before you can press this away button, all the doors should be closed. That is, all the zones should be ready. So this is the mechanism used in the program to simulate doors, because we can't have real doors. I mean, this is not a completely real system. So we are simulating the closing of the doors by checking these checkboxes. So this is door 1, this is door 2, this is door 3. So the check mark means they are ready. That is, they are closed. If they are all closed, you can press away. Then you have 1 minute to get out of the house. So at that point, of course, you will be unchecking this, and then because you are actually opening the door, and then maybe you are in the garage or in your front side of the house, wherever, and then you will be closing that, then you will be checking this again. Then after 1 minute, the system is armed, and when you open the door again, most probably because you are coming back to the house after 8 or 10 hours, coming back from work, and then you open the door. So this will become not ready, Then the system is armed. It will raise a warning, a little beep saying, enter your password. And you enter your password. In this case, it is always 1234, all right? You enter it, and then the warning is gone, and it is all back to normal, right? But if you don't enter the password, which is probably going to be the case if it is a burglar, then after a minute, the system raises a huge alarm, and there might be a monitoring facility which will call the police. And the police will be there, and hopefully will do something like catching the burglars or whatever. And if the system recognizes that security has been breached, there will be a huge alarm, and then you have to turn it off, you have to enter the password, right? The same thing is going to be true if there is motion detected in the house. We will assume that if there is movement in the house, it will be simulated by our pressing this button. So this is a button which you can click to say that somebody is moving inside the house. Maybe this could be, I mean, in our system, we will make it so that if there is motion in the house, it will again raise a warning followed by a possible breaching of the security system. But in a real system, perhaps, now I think this might actually immediately trigger a breach of security. But we will assume that it is treated just like opening a door. That is one thing. Second thing is, suppose at night you want to arm the system, then you again have to have all the doors closed, and then you press stay. Then again you have 1 minute for the system to be armed, and after that, opening of any door will immediately raise a huge alarm. There is no warning period. But if you move inside the house, nothing is going to happen. I mean, that is what you want, really, right? I mean, if you set the alarm at night, if you arm the system at night, you want to still move around inside the house. And if the system is armed, you can cancel it by pressing cancel and then entering the password. So that is what you need to implement. You need to have this graphical user interface created and have all the events and states and the state transitions implemented. Now there is a video that kind of shows how the whole thing flows, although it is not exhaustive, but you will get the idea, right? Now, this is due a month from today. I think it is due on the 1st of May. And typically, most groups over all these 6-7 years that I have taught this course, they have done better in the second project than the first, for whatever reason. I think one reason is that the biggest step, that the biggest bottleneck is actually getting the states and events and the state transition table nailed. Once you get those things correct, the implementation is fairly less tedious than the first group project. I'm not saying it is simple or anything of that kind, but if you use the microwave implementation, you can actually use that. Of course, all the events are different, all the states are different. You have many more states and events than the microwave, etc., etc. But that model can be far more easily employed here than using the library in your first group project. The pattern is much more obvious. So what I would suggest to every one of you is ensure that you get your state transition table correct before you actually implement the system. You can actually create the user interface, that is okay, but that is independent of anything else, right? I mean, creating this graphical user interface. But the rest of the implementation, you shouldn't venture into it unless you have your state transition table completely correct. If you make mistakes there, you had it. You will get a miserable, you'll have a miserable experience with implementation. If you don't have enough states, you will find that you're doing all kinds of conditionals, a lot of dirty code, etc., etc. If you have more states than necessary, maybe you are in the wrong path, or it could be that you will be having unnecessary transitions, but or whatever, which probably won't be incorrect, but what my suspicion is that if you have more states, then you probably haven't fully understood the whole model. I think that's probably it. But again, my biggest advice to you is to get your state transition table completely correct. And once you get it correct, you will know it. Okay. Till then, once you get it correct, there is almost no way that you will say, "Oh, is this correct?" That doubt will not come to your mind. I feel that way. Okay. Any questions? Oh, by the way, in your actual system, here I have things like saying 1 minute of warning period, etc., etc. I don't want to wait for 1 minute. Instead, make it like 10 seconds warning period or waiting period, and say maybe 15 seconds for the time to enter the password. Otherwise, you would just sit there and watch the clock ticking. You don't want to waste time for that. I also don't want to waste time for that. What do you need to submit? You need to submit the state transition table. You need to submit the state transition diagram, but I don't want you to draw the whole thing. You can draw the whole thing, no problem. But it is a lot of transitions. After a while, I don't know what I am testing if I ask you to draw all the state transitions, because I can grade you based on your state transition table itself. But I want you to get some experience in drawing the state transition diagram. That's why I'm asking you to submit it. But I'm not asking for the complete state transition diagram. I am asking you to draw all the states, which is rectangles with rounded corners, and then transitions only for some of the events. That is when some of the buttons are pressed, not all of the events. Then the second thing that you need to submit is the project, the Eclipse project in Java. You can implement the graphical user interface using FXML if you want to, but that can only be used for the interface, for creating this interface. No event handling, none of that should be specified through FXML. They should all be done in Java. Then what else? Yeah, you need to submit the project, obviously. You don't have to draw any sequence diagrams. I don't see the point in asking you to draw more sequence diagrams, because you have drawn a few in this project. So there is no real need to ask you to do that. Any questions? Oops, I have some nonsense here that is from last semester. I'm going to, I have to erase this stuff. Okay. I need to upload the new version then. Any questions? Okay. If you don't have any questions, let me emphasize again, the code that you write for the second group project is going to be very similar in approach to the implementation of the microwave, the second version, class project 2 version 2. So understanding that code will be supremely beneficial to your implementation phase for the second group project. And there will also be questions related to implementing state transition tables, etc., in the third exam. So you need to be quite comfortable with the code in the code for the microwave version 2. So all the questions in this evening for the class exercise are on that implementation. So are there any questions on this? If there are no more questions, I'm going to stop recording, and I'm